Hello. Hello everyone. Good morning. I am Neha Verma. I am a research scholar and I am having approx 9 years of teaching experience to engineering graduates. Now, for today, we will discuss about the reflection of light. That is the main property of light. So, we see here in our surrounding many objects are visible to us. That's because of reflection phenomena of light only. Because what is reflection phenomena? Suppose this is a clean surface, that is a reflecting surface, and a light is incident on it, then it will get reflected along the same direction with some angle. Suppose this is a perpendicular drawn on the reflected surface. This the angle between incidence ray and normal is called angle of incidence, and the angle between reflected ray and normal is called the angle of reflection. Here are some basic rules for the reflection of laws, normally called as law of reflection. First one is angle of incidence is equals to angle of reflection. Angle I equals angle R. Second one is this: the incident ray, the normal and the reflected ray. All the three rays lies in the same plane. There is none of them will go to another plane. Now, this is a plane surface phenomenon, plane surface reflection. Now, for example, plane mirrors in our home, which we use to see our images, and the images comes out from these mirrors is virtual, erect, and literally inverted. Now we come to the spherical mirrors. What are spherical mirrors? The mirrors which have their reflected surface as a curvature. The curvature should be of two types. One may be the curvature, that is this reflected surface maybe from at the outside, or the reflected surface may be the inside. Depending on this position of reflecting surface or the polished surface, we can define them as concave mirror and convex mirror. Let's talk about concave mirror. In this mirror, the polished surface or reflection surface is outside. So the object is placed here, and the light will get reflected at this, and its image will form here also. In case of convex mirror, this outer surface is reflected and object is also standing here, and it will get image at this point. That is, in concave mirror we have a cave-like structure, and the polished surface is outside, and in this convex mirror polished surface is this. Now, there are some basic terminologies used in these mirrors. Let's talk about these. These are the one: pole, center of curvature, radius of curvature, aperture, focal length, focus points, etc. Let's see here. This is a concave mirror here. If we complete the center of this concave mirror along this side is defined as the pole of mirror. Now, if we complete this circle, if we complete it, we will get a sphere of some center that is called center of curvature, and the distance between center of curvature and pole is defined as just like radius of a sphere. Similarly, here is spherical mirror used, so it is called as radius of curvature. Now, next point is focal point. We will talk it here. In case of convex mirror, if again we complete it, it will make a sphere of radius r. So we see the difference here, that in case of concave mirror, the center of curvature, the focus point, lie in front of mirror only. This is the mirror and this is the front of mirror. While in case of convex mirror, we see that image is formed here, and but completing this circle, we get that it forms a sphere of C, center of curvature, and F, focal length, that is behind the mirror. It is the front of mirror, it is the behind of mirror. Now, as we define all these things, this is center of curvature, pole of mirror, focus point. What is focus point? Let's see this concave mirror here. Now, suppose an object is placed at infinity, then by law we know all the rays coming to the mirror will be parallel to the principal axis. What is principal axis here? Principal axis is the straight line joining the center of curvature and pole, and it can be extended. So, along principal axis, the rays coming from the object will be parallelly incident on mirror, and at all these rays, these are incidenting on the concave mirror here, will get interacted on the will be reflected, and at a particular intersecting point they will be meet. So this is the point where these all refracted ray, this comes along this and go through this. This come along this, go through this. Similarly, this ray go through this ray go through this. Here what we see that all these converging rays or the reflected rays are intersecting at this common point that lies on the principal axis, and this point is named as focus point of this mirror. Similarly, in case of convex mirror, when object is placed at infinity, all the rays will be parallel to the principal axis and gets reflected like this. This ray moves along this ray moves along this. Similarly, this. Since it is a mirror, so they are reflecting from this point, but they appear to come from a certain point that is behind the mirror. This point is named as focal point. This is the focus of this convex mirror here. Now, what is aperture? Aperture is the mirror we used for the our measurements only. What is focal length? Focal length is the, for small apertures we see this apertures where radius of curvature is far greater than aperture. Aperture is this point. This is mirror size. Then the focal length is given as r upon 2. That is, it is half of radius of curvature, or r is twice l. Using this formula, we can calculate the focal length or the radius of curvature if any one is given in the question. So this is the short demo on the reflection of light topic. Thank you so much.